This will just be a quick video showing the teardown of this new walking robot I built. It's more or less a pin walker with the pin walking mechanism turned inside out. Instead of a pin being in the middle of a stationary leg, the pin is more or less stationary, and the leg moves in an elliptical motion to move the toy. This is the pin staying more or less stationary. The legs are moving elliptically. This knee joint, this is just an aesthetic addition made up of two parts with pivots made from T-pins. It's pretty simple. They don't actually provide the motion of the walking motion. There's also some added animation of the arm swinging. This top of this leg right here has a little pin. Might be able to see it right in there. It drives the arm back and forth opposite the leg. I'll start tearing it down now to show you what's inside of it. One of the problems I ran into was I ran out of room for this, getting my finger in to flip the switch off, so I had to use a screwdriver. First of all, there's a screw that holds the top of the head to the bottom of the head. It's just a 2mm by 8mm screw. It's not on there very tight. This is the access to the charging of the battery. You'll want to, don't short those out. You'll want to put some either heat shrink or hot glue on those to insulate them. But battery, it's a 150 milliamp battery, and it can provide quite a bit of current. The arms are held on by this threaded bolt, shoulder bolt, oddly enough. The bolt has a shoulder on it. I'll show you that. So it can only go in so far. I hope some of this is in focus. The body is held on by a, these shouldn't have to be on there that tight, by this little threaded screw. These are 6mm threaded parts, printed with 100% infill. In the front, there's just a 2mm by 8mm screw, same one as the head used. I ran out of room for getting a 3D printed part in there, so I just used this. After you take the arms off and those two connectors out, you can remove the body. This head part is made in two pieces. The bottom part's glued to the main body. That's held on with the screw. Here's the inside of it. We have a N20 gear motor, 100 RPM, 6 volt. I believe that's what I used. A little hot glue to keep it from moving. These two gears make up the 90-degree drive for the shaft. These are the drive pins for the arms that move it back and forth. This part right here, the most inside part, comes down here, and it's the leg that moves in the elliptical motion. Make the foot of it is made up in two parts. That inside part, which is one piece, with this half foot part glued to it, super glued to it. There's actually a pocket you can to help locate the two parts together. You may be able to see it right there. The next part is the pin, that stationary pin, and then this I guess you call it a facade. The lower leg and upper leg that are hinged together with the T-pins. The shaft is made of 3mm brass, well, 1/8" brass brazing rod. You could probably use 3mm rod. That's just what I had. To take it apart further, we'll unscrew it shouldn't have put those so tight. It's not necessary. You have to print those in 100% or they'll bust off on you if you're not careful. You can see with the shaft and the crank has little timing marks on it. The one on this side should be 180 degrees from the one on the other side. So this one points this way, the other side will point that way. You can see the leg I just took off, the three parts that make it up. This leg pin, I believe that's the file I called it. I still got some glue from the build plate on here. The half foot, the top leg, the bottom leg, and the drive pin for the arm. This pin has a recess in it. When you assemble it, you want to put the recess toward this part. That's in case you have to use a little bit of hot or a little bit of super glue to hold the crank to the 3mm shaft. There's a little bit of relief there for it. Hopefully it won't bind. I'll take the other side apart now. There you can see the whole shaft assembly. What holds the shaft in place is this part here, which is called the clamp. This is called the frame. There is another 2mm by 8mm screw down in here. You see this is angled. You take that screw loose, and you can just pull that out, remove the shaft. This battery is from a little drone or something. I bought them on Banggood. You get them like 5 in a pack with a charger and with charging cables for $12, I believe. One of the hardest part of the build is the wiring. This wire that came on the battery is not very flexible, so I added this ribbon cable from an old IDE connector cable. It's more flexible. You will need to be careful when you're splicing things with these little batteries. They have a lot of juice in them. Use heat shrink. Make sure you don't cut both wires at the same time. Just don't short them out. You can see I've spliced those on. Going up here, that's the original connector from the battery. I did go back and splice onto that. What they're connected to is the little charging cable that comes with the in the set. Here's Here's the charger for it that you get with one of the cables hooked up to it. It runs out of a USB power supply. And the switch is from a common tea light. I've disassembled it. There's also a battery in there. The switch has to be mounted about 1 millimeter proud of this frame. In other words, it has to stick up about 1 millimeter. The reason for that is, I'm not sure I'll be able to show it. But down in the bottom of the main body is it's made to receive that switch. That also locates the body so that it doesn't do this. Keeps it from pivoting. So you have to mount the switch about 1 millimeter proud. I attempted to make some channels in the frame for the wiring. One side it worked okay. I probably should have super glued the wires in there. Would have worked better because you have to thread this all up through this hole when you're assembling it and hit that hole in the main body that the switch comes out of. I just ran out of room in there. Well, that's about all I have to show you. There is a quarter. This is the front of the main body, and I've double taped a quarter in there. I thought it would walk a little better with it. I'm not sure if it does or not. Just to get the balance a little more forward. And that's about it. I'll put the files on Thingiverse or Instructables or somewhere, and I'll link to them in the description. I'll put a lot of pictures at the end of a video and wherever I post this. So thanks for watching.